expected to start at 9 o'clock, now it is 10. Next day means Friday, I guess we should start at 9 or 9:30. We should decide that today is I guess everybody knows my name. It's not new, I guess. Anyway, let me write it in case you don't know it. W. Ramasinghe. My name. W stands for Vimala Ragna. And you know, Vimala means precious, very precious. Ragna means gem. So I am a very precious gem, right? I guess that's how my parents saw me when I was born, no? They are the people who put the name, no? I mean, this is what I tell to American students always on the very first day of the lecture. And I guess I don't have to understand whether you can understand me or not because we all are Sri Lankans, I guess. Everybody is single or are there Tamil students here? Single. So, Prabhat told me to conduct a lecture in English, and so I will do so. But in case you cannot understand English, what I say, you can ask me in Sinhala, I can reply to you, either in English or Sinhala. Because language is not a problem for us as far as this course is concerned. We are interested in not the English but mathematics. So, however, if you know English, it's good because we learn in English now. And so far you have been doing mathematics, I guess to this day, before you start reading this book by Tao, Terence Tao, your mathematics, I guess, has been something to do with the numbers. But then you may have developed an impression that mathematics is something to do with the numbers. That's not true. That's not true at all. But to the contrary, till A-level, or else man in the street thinks that mathematics is something to do with the numbers. I mean, in maths actually there are no numbers. That's the thing. Because always, we get illusions. Mathematics is made of 7 things. So we need to understand that out of the 7 things, 5 things in this course very well, I guess. Other 2 are not that difficult. Nothing is difficult in maths, by the way. If you understand, then you will enjoy this. When people say, sometimes when people say, oh, that problem is difficult, because they look at the problem, it has 4 or 5 pages, some asterisks or something else, then they say difficult, because actually in maths, when I was teaching analysis in the States, if somebody tells me some problem is difficult, I ask him over to prove that it is difficult. I mean, you cannot just say that it is difficult. There must be a reason. I mean, for instance, there are problems which are unsolved. You might know, you may know some of them. So there is some problem that we could not, go through. That's why we say it is difficult. But usually textbook problems, and they, of course, some problems may be somewhat difficult to solve, but all I am saying is just by looking at the problem, we cannot decide that it is difficult. So, Sri Lankan students, oh my gosh, sir, this is very difficult. I ask, look at it. How can you say just by looking at the problem is difficult? I mean, again, you need to like and you need to enjoy the difficult problems. Solving something very easy is useless, no wasting time, no? So you become better at maths or good at maths by trying to solve difficult things. you get a kick out, like that 3n plus 1 problem before coming to you. No, you know this one, no? Do you? Don't know? Those who don't know? Anyway, let me explain. Thank you. The 3n problem is that, suppose you begin from 3n plus 1, it has a different name also, Halifax. I cannot remember. I am out of touch for 5 years. I retired in 2020, April. Now this is 2025, years, more than 5 years. Actually, these are the 2 books I have written. I have written so many books. Then when I went through this, these days, this last 3 or 4 days, I found it difficult. Because I haven't done it. After I retired, I wrote only this book, this one. And I wrote this one again in Sinhala also, it is yet to be published. This is a very good book, by the way. Though you told me you want to learn the basics, this is a real good book. And it is only 185 rupees. This is published by the Educational Publications Department. So they don't try to make any money. Anyway, so let me say 3n plus 1 problem is, so this is not the real lecture, we have to start real lecture. Because actually because I myself have written many books which cover the undergraduate, not the special degree, other analysis. They are very good books. So then Prabhat told me to follow this book. Then when I go to here, there are different notations, this and that. So I myself have to study. So life won't be easy. It's good. For me it is good. I wonder whether it is good for you, because sometimes having many different notations won't give you anything. That's right. Anyway, 3n plus 1 problem is good for you to know. Say suppose you begin from any number, say let's take 3. 3 is an odd number. So first you do is, if it is odd, you multiply by n. You multiply this number by 3, then add 1. That's why it is called 3n plus 1. If it is odd, multiply by 3 and add 1. So answer is 10. Right? It is a function f of n is 3n plus 1 if n is odd, and it is n divided by 2 if n is even. So if you start from 3, you first time you get 10, then you apply it again, then you get, if you apply this f again, what will you get? 5, right? Now if you apply it again, 16. If you apply it, all these spades are like, let's see, U and Pippin. If you apply it again, you will get 8. And if you apply it again, 4, if you apply it again, 2, if you apply it again, 1. You ended up with 1 by applying f recursively on 3. Now let's go, give me another number. Say 6. No, 6 is also not good. Let's say 10. If you apply, what will you get? 5. You get 5. Now, if you add 5, you go to 1 again. Let's take a little bit big number, 13. You get 40. Then you get 20. Then you get 10. Then you get 5. And you go to 1. So conjecture is that given any n by applying f repeatedly many times, you will come to 1. So this is an unsolved problem. I have tried to solve this many times when I was in USA. I tried to use the computer to get something because when it comes to mathematics, computer is a partial fool or a complete idiot now, because it cannot think at all. Computer cannot think. It does what it is asked to do. No? So anyway, sometimes some sort of a glimpse or some motivation you can get from a computer, but not maths. Anyway, I tried where I couldn't succeed, but whole world has tried for during the First World War time. They have tried, nobody was able to solve it. So that is a difficult problem. Not the problems about f equals a, or about the circle or straight line. I mean, they are not difficult, because only thing is you haven't. If somebody says, if an honest student says that it is difficult for him, maybe he or she hasn't seen what to do, but quite often in Sri Lanka, when the students say a problem is difficult, I just by the words or by the appearance, it's like that. So, anyway, so you got to know the 3n plus 1 problem. So, you don't have to do this course if you can solve this problem. I suppose you will get quite a lot of money. I cannot remember how much you have.
1 million.
1 million? $1 million, no?
Yeah.
$1 million. So we can tell Prabhat, we are going to meet the class and start solving 3n plus 1 problem. But you know what I think is always, maybe there is something in our, this daughter said that she wants to learn basics about mathematics. Maybe there is some little tiny thing in basics that nobody could see to this day. That's why it is not solved. That's what I think. That's what I think. That's, as a result, you should try. Because you may not see the things that the rest of the world hasn't seen to this day. It's a possibility. Don't give up. However, just because I say you should not try, no, now let's go to 25, then you go to 76, then you go to 38, then you go to 19, then you go to 58, then you go to 29, like that. By trying 4 numbers, you are not going to learn. But good for you to see. Good for you to see for that any number, to any number that you start, it goes to 1. But he cannot, he can of course conjecture, it is a conjecture. But cannot show it, it's not shown to this day. Then the reason I said this was that many problems that normal student or every student says difficult, these problems are not difficult actually. They haven't tried. No? Especially in our culture nowadays, students go for tuition. Then tuition solves all the problems. They cram the solutions. No? They cram the solutions. Now, first part of this course is to discuss about logic. Today and maybe also Friday. Mathematics is a highly logical thing. That's, if you know logic, you don't know maths. But in order to learn maths, you have to learn logic. Sometimes arts faculty, there is a subject called logic, no? I think. But they cannot do it. So we have to be very precise, that is the thing. All right, so I was going to say that mathematics usually, when I wrote the book called Ilanga Pada, have you read Ilanga Pada? Nobody? Come on, that's not good. I thought that you know something about it. Anyway, I can tell you, when I wrote the book Ilanga Pada, I wrote in single. You know, next term, Ilanga Pada English, this next term, I was interviewed by one young girl, Rupavahini. No. What is this? Wrote SLBC, Sri Lanka Broadcasting Corporation. I don't know these names. She was an arts faculty student. The one who interviewed me. Sir, I couldn't believe that you wrote such a book. Seriously. Anyway, so before I start the lecture, let me say that also to you, although it is not logic, our lesson today is about logic, but to know this kind of things also very important, because mathematics is, you have background knowledge is very important for you. Very important. Just because of you are intelligent, you cannot do maths. You can. Insight, intuition and insight are absolutely important. I mean, what is the tallest building in the world? Burj Khalifa. I mean, if you want to do that, Burj Khalifa is the tallest building in the world. Actually, then you have to know what is the tallest tower in Thailand or Taiwan?
Malaysia, the Twin Towers.
Not that one. Taller one in Thailand or Taiwan, what's the name? There is a taller one, much taller one. I have written them about in these books somewhere now, I can find. Let's not do that. Anyway, to prove that Burj Khalifa is the tallest building in the world, just because of you know maths, you have 3 years in A level and BSc first class, can you prove? No. You have to have background knowledge about tall buildings in the world. As he said, Twin Towers in Malaysia, that you haven't heard of this. Taiwan, Thailand, I cannot. Now you understand that I am at least 5 years older than you, no? I cannot remember many things. So that background is very important for you to prove. Because you are very clever, you cannot prove Burj Khalifa in Dubai is the tallest building in the world. Same thing is true in maths, you have to have the background knowledge. That's why these kind of things are also important. Not only logic. So, what was I going to say? I forgot. No, I was before logic. Then another thing I wanted to tell you, no? Next term, So, I mean, I usually ask if 1, 2, 3, 4, what's the next term? This is a, sequence of numbers, first 4 terms respectively are 1, 2, 3, 4. I usually ask, what's the next term? Daughter, what do you think, what's the next term? You say, answer this. අපි අර මේ මෙතන කතා කරන්න ඕන හරි ගියයි වැරදුණයි කියන එක redundant. Whether you tell me you correct answer, I don't care. If you tell me the right answer, again I don't care. But when it comes to logic, if you are thinking logical, I will buy you an ice cream. What do you think? Do it next level. 5. What are you? 5. Yeah? 5. Me puta? Would be anything. Where puta? 5. Me puta? I don't want to ask cameraman. Otherwise he will run away. So, if somebody asks me now, you say 5, no? So, if you want to ask, prove it. Maths is nothing but proofs, no? Not simplifications. Now our A-level exam is not a math exam. No? It's not math. You simplify so many things. 1, 2, 3, 4. Next time this one. Then people say, prove it. So then you write, say x, you say xn is equal to n. Then you check x1 is 1, x2 is 2, x3 is 3, x4 is 4, x5 is 5. That's the proof. Sometimes you may write it this way also. Fn equals n. Then f1 is 1, f2 is 2, f3 is 3. But I told you my lucky number. What's your lucky number? You should have calculated. Anyway, my lucky number is 7. Sanajay Surya's lucky number is 7. This guy, the Australian Gilchrist, I guess, guy who beat us last cricket World Cup. This lucky number is 7. Mine is also 7. As a result, I say next term is 7. Then people ask, prove it, sir. Can you prove it? Then, of course, I say I can prove it. Then, how on earth you can prove it? First one is 1, next one is 2, next one is 3, next one is 4. Then next term must be 7. It goes without saying, that's what I say. But I say now look at this formula, Yn. Yn is equal to n plus n minus 1 times n minus this u in p pen also doesn't matter. Now let's see, communist DNP pen. n minus 3 times n minus 4 divided by 5, no? Basic. We have this formula. Now if you plug n is equal to 1, y1 is 1. Right way? If you plug n is equal to 2, y2 is 2. If you plug n is equal to 3, y3 is 3. And if you plug n equals 4, y4 is 4. But if you plug n is equal to 5, y5 is. How much is total? 4, 3, 2, 1. Over there, n 1, n minus 2, n minus 3, n minus 4 times 2. Do 7. Now I have proved, no? 1, 2, 3, 4, next one is 7. So actually my Ilangapade book is about this. And if you are saying the next term after 1, 2, 3, 4 is 5, I mean, then you don't think out of the box. Right? It can be any number. It can be any number. Say suppose I want it to be alpha. I claim it is alpha. Then what should I do? I write here alpha minus n. You know? If n is equal to 1, 2, 3, 4, you get 4. Then if you plug n is equal to 5, these things 1, 5 plus, here should be alpha, sorry, alpha minus 5. Then you get alpha. So it can be anything. So I told you this thing because you have to be ready to think out of the box. If somebody says, actually, now they say when I was a student doing my BSc, university people were regarded as the best, that is the highest job in the country. Central bank was the second. But nowadays, there is a contradiction. Everybody has read the book and you know the meaning of contradiction, no? So, now there is a contradiction. You know what the contradiction is? To central bank, they get the first classes from universities. From Moratua, Colombo, Ramasinghe and so on. They get the first classes. Now, who will be working then in the universities? Second classes, no? Then, in the years to come, graduates are produced by not first class people, second class people. So they cannot be that good, no? To produce better, good students, we have to have the best in the university, not in the central bank. You understand my point? Because central bank, they get from, like fishermen, fishermen don't cultivate fish or don't go fish in the Indian Ocean. They do kind of go and leave it or something like that. They fish, no? So it's a problem now. Actually, they have a test to take to the central bank now, so there are many questions, most of the questions. Next day I will bring my many questions are, first term is 2, then one is 4, next one is 6, then next one is 8. What's the next term? Only people with no brains go to central bank. Actually, after I wrote the book, there were many letters written to central bank. That person called Dr. Ramasinghe has written such a book. Why on earth still you are writing this sort of problems for the selection test to the central bank? We don't understand this. Anyway, now let's quit there. Now let's come back to not to the lesson today, but still somewhere close to the lesson. So try to solve that 3n plus 1 problem because you are young and must be maybe able to solve. Because you know about the structure of the benzene cell, no? Benzene cell structure, that's also important for you to know. Scientists couldn't discover. They did many experiments, but they couldn't discover the structure of the benzene cell. Then guy called Kekule, he used to think about this even before he went to bed those days. One day he saw a dream. Some snakes, they are in a circle, one snake's tail is in the other snake's mouth. Then this guy thought, think about it, following it. So in his head, this guy looks like a snake. So and you see, this thing is in his mouth. So then only he came up with this benzene thing, 1, 2, 3, 4, 5, 6, I guess, and it is, you know it. Then they did the experiments for many years and only justified that it was the right thing. So this was sold not in a laboratory. From laboratory experiments, people couldn't discover the structure of the benzene. That's why there are many things, say malaria vaccine, nobody could find. That's why when I was in USA, I was at the Ohio State, I was a professor there. I was asked to join they have an institute called Medicine and Mathematics. They are working on diabetes cure, heart attack cure, this and that. So, there are 250 people. There were, I don't know how many now there are, I don't know. Keeping up the records. So I was also asked to join because I am an analyst. Many people were there. 200 people were mathematicians, 50 of them were doctors. When I came back to Sri Lanka, I was selling this thing at the University of Colombo somewhere. That I was asked to join the group of researchers, those who are researching on diabetes, heart attack, and so on. Sir, that means you are going to find the derivative of sin x and derivative of x squared or sigma 1 over n. They think mathematicians are doing calculus problems. That's not true. That's why you have to mathematics is nothing but how we think. It's not simplifying things. So people have a very wrong impression that mathematicians do simplifications. We don't have to do by there are calculators, computers. They will do these computations much faster than us. Then, I don't know, I heard that now AI is going to solve even our difficult math problems.
Yeah.
Yes, I cannot believe.
Did you look for got a gold medal in IM?
But you said computer got a gold medal.
No, an AI.
Eh?
AI.
Yeah. But then Terence Tao has said that it's not that AI got it. AI was supported by mathematicians, those who knew good maths.
Yeah.
He has written an article even to India Today, I guess. That's something. So I don't believe that AI will be able to solve something none of us can solve. I cannot imagine. I cannot claim, but I cannot. Even I cannot imagine. I cannot imagine now 1 over 1 plus 1 over 2 plus 1 over 3 plus. If I add continuously, how much will be the answer? Eh? What do you think? Some say infinity. What do you think? You can understand. We are adding 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5 plus and so on. You said Kuta infinity.
It's divergent.
Kuta, you said also infinity. Do you use it? We are saying?
Divergent.
Why do you say? Anyway, let's not get into it because we are coming to it in our analysis course now. Analysis course, we are coming to it. What I am going to say is that check whether one can come up with a computer, produce a computer which can solve, which can prove that this series is divergent. I wonder whether one can do it. One can produce a computer which can prove that this adds up to infinity. I am wondering. According to me, nobody can build a computer which can prove this. According to me. The reason is that after adding so many terms, even to say you add this thing for 50 years, whole world, now 51st year. Then let's say after 50 years, sum is like 6, 60, 72, 850, and 1000, 2025.6. Assume after 50 years, whole world adds adding this thing without eating, drinking, going to restrooms and all, without doing anything. You came to this number. Then, he said, no, let's write some more, 7, 0, 8, 9, 3, 1, something like that. Let's assume. Then, for this thing to become 7, 0, 8, 9, 3, 2, it takes another 50 years. I'm just giving an example. I will show this thing. We are doing analysis now. So that's why Buddha, I cannot believe that somebody
But
can.
if we can prove it mathematically, not to like computationally brute force to it, but we can use a proof, right?
We, of course, we
Yeah,
are going to
proof.
prove it.
Yeah. So like we can create an AI which would think like a human, and that AI can prove the same way the human thinks.
Then he is cheating, no? That AI guy.
Yeah, I mean that is like the definition itself is right. If we can like
No, what I am trying to say is this. Now you are, say, suppose engineering faculty students, they want to say, if they are don't study geomaths, if they are this thing, what they will do is they will get like 50 students, add for engineering faculty time, 4 years time at the University of Moratuwa. They add, they get to some number. Then they check for another 1 year, that number won't change. That's what happened. They take another 1 year, again it won't change. Then take another 1 year, it won't change. Then what will be the decision of the Moratuwa students? That number is the sum of the series. That's right, my point. Not the proof that we give is going to be copied by the AI. I know. So I wonder, any of that, think about it. I don't know. Others also. I'm not going to go in today. It's not today's job, but so let's get somewhere close to our lecture. So mathematics, as I was saying, many people think that it is something to do with numbers. No, actually, I told you my lucky number, my number is lucky 7. Lucky number. So mathematics is made of 7 things: plus, dot, and not, and not, and O implies if and only if. Mathematics is something made out of these 7 things. So we are going to learn that in this class before it is over. 7 things. These are called binary operations. These are called logical connectives. Connect, C-O-N-N-E-C. Logical connectives. So our goal is to learn about this, to understand the meaning of logical connectives. This class, I guess, could be, so according to this book, it has only in the appendix, but we will spend some time, maybe today and Friday, to get the meaning of not and O implies if and only if. Actually, they are English words. They are English words. So you need to understand that in English, not has some meaning. In maths, it's a different meaning. Maybe somewhere close. And also the same way, O also the same way, implies this is missing. And if and only if. So they are called logical connectives. So logical connectives connect statements. These and acts and is called a unary operation. Unary, U-N-A-R-Y. I guess my spelling is correct. These are binary. Binary connective. Binary connective means they connect two statements. You have some primitive or preliminary, some basic statement, and it connects two statements and make a more complicated statement. Not this one. I said, oh, Anjali, I know you know that already. Not is a unary operation. If say some you have x is equal to 5, not x equals 5, like that. Here and here. X is greater than y, 2 is equal to 5. Then you can connect these two by x greater than y and like that. But you see them in coconuts and mangoes. That N is not mathematical N. Papayas or oranges. That O is English O, not maths O. Like that. So we are going to pay attention to these 5 things, 5 logical connectives today and I guess on Friday. If you have read the book by the way, I'm also like you. I retired from the 2020. I did not do anything except the fact that I wrote this yellow book and I visited Mata Sujata Vidyalaya after retiring. And I conducted some lectures for teachers, Colombo area, about this concavity, Uttalata, something like that. Like a factor. I wrote a little book actually. So I myself have to read this book to learn. In a way, I'm getting tired because I am a person who has written books for these. Now this real big shot has written book and he has different notations and so it makes my life a little harder. But what to do? So both of us are in the same boat. No? I mean, you are, both of us are at the very beginning, no? Although I know now, then I look at the first chapter, then the one, he has this 1 plus notation. So somehow, then Putato showed me that Cauchy sequences, he has some, not the same thing that we have been using. Actually, I want you to know that I took like, I don't know how many years, at least 8 years to understand the meaning of a Cauchy sequence. Is that difficult? Because it's not, I'm saying it's not what you cram, what you feel, no? Logic, I did not write notes, but only 2 pages. Only 2 pages. I have written, you should not cram logic. Shall I write on the board? You want to take down notes? So, anyway then let me write it. But no pen is working properly. Well, the thing I told you is true. I am also in the same book with you. I wonder why he has introduced this new notations. Logic, you cannot learn by cramming. you cannot learn. I told you, no, it took like 8 years for me to get the real meaning of a Cauchy sequence. But if you are students, my students, they don't get that long because I have struggled, and learn it by sweating a lot, no? So somebody who learns from me certainly will have an easier time. Anyway, so most important thing is you cannot learn logic by cramming. That is why many students in Sri Lanka find mathematics is difficult. Not only here, even USA the same way, because I was there for many years. But the difference is in USA, there are, it's a big country. I was at Ohio State. State of Ohio is bigger than Sri Lanka. And the difference is over there. Those who are good at maths, they come to do maths. In Sri Lanka, those who are good at maths, they go to engineering like this daughter. No, I'm not blaming it, but that's the thing. Let me write. I don't have much notes, but actually when I was asked to teach this course, I was very happy because I am a person who enjoys teaching analysis a lot, giving problems. So yeah, it's a real fun thing. This is very amazing, no? Very amazing because you are a royalist, no? Then I was in Colombo University. I was the chief guest at Royal College. Chief guest for 12 years consecutively. This year, next year, year after next year. After 12 years or so, I got very tired. Because the reason, every year I went, I gave a different set of problems. These problems are not from books. And these problems are not to be solved. Some of them. Just to be read. Only to read. Because by reading itself, you get so much of fun. My gosh, can it happen? It's like that. So, I mean, I was there. This is one problem. I say here, I mean, this is very simple. A1 plus A2 plus A, I say each A is positive. I say this is, for instance, is infinity. I say, then I will ask, how about these are very simple, however, if you know the answer. What about this thing? Is still infinity? Because I like the argument of, you got to know the problem is you have a sequence of numbers sum to infinity. Some bunch of numbers. Oh yes, so if you want, if you don't like infinity, you say 523. Some number. Then I ask, what about when you add square root? Then they say, sir, when you add without squaring, the answer is infinity. Then say it goes without saying that when you square it, it must be the square of infinity. But the square of infinity is also infinity, and hence this must be infinity. So royalists, I mean, they are young boys, no? Only not Royal Maths Day is not only for royal students. They invite, still they have Maths Day, no?
Now they don't.
Now they don't. Because actually when I quitted, the last year, I said that I cannot go because I have to prepare. If I have at least one problem set at home, I will bring it to you. A copy, I will give it to you. So I have to prepare new problems. Why? Because the principle is same principle. Teachers are same. If I am doing the same thing, the other thing is students, they also want to say new things. I got tired of creating problems. Very tired. Then they invited them. No, they told me, they usually, I cannot remember, during in the middle of the year they take the mass day. Then that year they told me when I said that I couldn't come, sir, you give us the day. We will arrange it for that day. Then I postponed. Then during the month of November, sir, now we don't have much more time. Now we have to decide. Oh, no, I cannot come. Then they invited somebody from another university. What happened was that person cannot create this kind of problems. IO students were very happy. They made some noise also, like that. Boys like to do that. Then they didn't want to have mass day for a couple of years. Now you are saying they don't have it. No. Too bad. I enjoyed a lot actually going there. They are good. Guys who are good. Anyway, let me write something. Of course, design this book also. In my book, it's a little bit different. But I guess in this main form, this course is to follow this book. Let's do that. The disadvantage is that I also have to study. Anyway, let me write something here. You should cram logic. It is useless. Try to understand it. We do not consider this pen also. I don't know. These are provided by the institute, no? Pens. But we do not consider ill-formed. This one is the good one. Ill-formed or ill-defined. Statements in mathematics. By the way, these words ill-formed and ill-defined, they are not my words. That's why I picked it up from this book. No, you have seen it, no? You saw it. So, to me it's new, but since we are following the book, we need to learn, we have to get.
Sorry, are you gonna write the whole thing? Are you gonna write the whole thing on the
So
book?
we can take like a picture of it and put it to the group? The note?
It's okay.
Yeah, so you have to write it.
Yeah.
Oh, we can do that. So, can somebody do it?
Yeah.
Then Ali can
No,
talk about
take
it.
a copy there.
No, then
බලන්න
ෆොටෝ එක ගහලා දෙන්න මම කතා කරන්න යනවා ඒක. Because we need to go through this logical connectives. now everybody is getting the copy right now.
Yeah.
Okay, so let's talk about this thing a little bit because we have to cover the 5 logical connectives, meaning of the 5 logical connectives, then quantifiers, existence of quantifier, universal quantifier. Then we have learned the word negation, contradiction. I mean, negation comes under, of course, logical connectives. Word contradiction. So this ill-formed is a word in this book only. I have not seen any other because I have read so many maths books, but I have never seen that word in this, any other book. Ill-defined or ill-formed. No, that's how we have written. That's the only reason I also wrote it. But then we consider only well-formed, or well-defined. This is the word I am familiar with. Well-defined means after you define it, there is no ambiguity. That is the meaning of actually well-defined. There is no ambiguity. The meaning statements that we write in maths are meaningful. Let's read it. No, then we can talk about it. We consider well-formed or well-defined statements in mathematics. So well-defined has the English meaning. Well-defined has the English meaning. If you say something is, say, if I say, say my brother, if it is well-defined, that means there is no ambiguity. You can understand what my brother means. That is the meaning. So, because his mother tongue is English, no? He knows so much of English. So he has come up with, and he is a big shot, so he has to read them. No? I cannot do that to the world. Somehow, I am going to send this book to him and see what he says. If he at least is going to share 1/10 of his previous medal, that wouldn't be bad. Therefore, I mean, saying these statements are precise. They are either true or false, but not both. Very important. If you take a statement that we consider in maths, they are either true in English or else false. In English, when you say POQ, anything can be, but here either true or else false. Cannot be both. That kind of statements are considered in English. For instance, let's say this daughter. Somebody wants to say, this daughter is a nice girl. Certainly, her mom agrees. But if you ask the neighbor, we will get some other, opinion. So, daughter is a nice girl is not a well-defined thing. You understand? I just gave you an example. So the statements we consider in maths, its meaning has no ambiguity at all. It cannot be kind-hearted, and it cannot be, how old are you? How old are you cannot be a statement considered in mathematics. Why? What's the reason? What's the reason?
It's neither true nor false.
Very good. It's neither true nor false. This one has a correct answer. but it is neither true nor false. You understand? So, questions are not considered in mathematics. In the proof, therefore, to prove a statement in mathematics is true, it is enough to show that it is not false. Because either true or false, no? If you want to prove a statement is true, it's enough to prove that it is not false. Then they are either true. Therefore, to prove a statement in mathematics is true, it is enough to show that it is not false. Similarly, to prove a statement is false, it is enough to show that it is not true. It's unclear, no? It is important to understand that the truth or falsity of a statement is intrinsic to the statement. Very important statement. And does not depend on the opinion of the person viewing the statement. Truth or falsity is an intrinsic thing of the statement. Somebody observes, asks questions, their opinion is redundant. Intrinsic, what is the single word? Cannot remember. Intrinsic. And everybody knows meaning of intrinsic? Intrinsic. කියන්නේ මොකක්ද සිංහල වචනේ? කියන්නේ ඒක නිකම් වෙන්නේ. ඒකටම ආවේනික වෙච්ච in Sinhala. It's characteristic of the statement only. The others have no opinion. Intrinsic to the statement and does not depend on the opinion of the person viewing the statement. It is not dubious at all. Dubious means suspicious. Certain. That kind of statements are considered in mathematics. Because the reason, as you know, mathematics is a language, no? In a language, there are statements. When you solve a problem, if there are no statements, that is not a math problem. It cannot be a math problem. In the math problem, when you solve it, solution must consist of statements. Either true or else false, but not both. There cannot be statements like Kamala is a beautiful girl. Because Kamala's mother says she is, the neighbor says, oh my gosh, don't ask me. In other words, the meaning of a statement considered in mathematics has no ambiguity. For instance, the statement, the square root of 2, very important one, the square root of 2 is approximately equal to 1.414 is ill-formed. We say the square root of 2 is approximately equal to 1.414 is ill-formed. So it cannot be considered, you cannot write that statement in a mathematical proof. Because somebody, you say 1.414, he says, no, 1.4143. Can you see, it's not perfect. So, is approximately equal to, is not a pure mathematical term. It's not. It is not at all. And the statement, the sequence square of 1.414 is equal to 1.39 and 396 is well formed. Square of 1.414 squared is equal to 1.999396. This is well formed or well defined. Now, you know, if fact students, for instance, write this way. So, this is not mathematics for us. සිංහලෙම කියනවා නම් දෙකේ වර්ගමූලය ආසන්න වශයෙන් 1.4යි වේ කියන වාක්‍ය වියෝමස් ප්‍රූෆ් එක ලියීමට නොහැකියි. ඒකයි මම කිව්වේ. හරි. Statements are different from expressions. That's also important to understand. Statements have a meaning. They are either true or false, but not both. Expression is a sequence of mathematical symbols that produces some mathematical object, such as a matrix, set, function, etc. For instance, now I have it in here, you have it in your notes, 2 cross 4 minus 7. This is an expression. You cannot say this is true or false. You cannot say this is true or false. This is an expression, not a statement. It produces a number as its value. Hence, it does not make any sense to ask whether 2 cross 4 minus 7 is true or false. You cannot ask. Meanwhile, 2 cross 4 minus 7 equals 10 is a statement. Now, if you write 2 cross 4 minus 7 equals 10, this is a statement. You can use this in the proof. When you are writing a proof or shown in the math problem, this is something you can use. Because it is a statement, it can be, it is not an expression, so it has either true or false. What is this?
What is it?
Nikamma. මේක ඉන්නේ zoom එක කනෙක්ට් කරලා නෑ මේක ඔෆ් කරලා මොකද කනෙක්ට් කරලා
කියන්නේ මොකද?
නෑ මයික් එකට කනෙක්ට් කරලා තිබ්බ මම දැන් මයික් එක පාවිච්චි කරේ නෑ
ඕනේ නෑ නේද? මම පොඩි කට්ටියකට මොනමයි. Now, another example, 1 plus e to the I5. 1 plus e to the I5, this is an expression. However, you cannot ask, is it true or is it false? No meaning. It is just an expression. However, if you write 1 plus e to the I5 is equal to 0, this is a statement. Statement. Actually, it is a true statement. No? It is a true statement. So here, the new good thing is because some people read books other than this. In other books, you will find well-defined only. Not well-formed also I haven't seen. There's ill-formed or ill-defined only in these books. To this day I have seen only in this book. Then we are going to learn something. There are 5 logical connectives. Not, and, or implies, and if and only if. Not is a unary connective. You understand that? Not acts on one statement. And or implies, and if and only if are binary connectives, they connect 2 statements. So you need to understand apple and oranges. When you say apples and oranges, that and is not mathematical. It's just ordinary English and. Okay, first word we are going to learn is conjunction. Again. Conjunction. So now you have to think that I told you mathematics is language of science. No, there are statements. So statements are connected by not, and, or, implies, if and only if. Now when you connect to, again this book used capital X, capital Y for statements. This is the only book I have seen that. Maybe there are other books, but I haven't seen. It doesn't matter. If X and Y are statements, then a statement I have, let me read because you have it. A statement of the form X and Y. Of the form X and Y where x and y are statements, is called conjunctive statements. Can you see from the two statements x and y, we get another statements, x and y. X and y are is called, this thing is called a conjunctive statement. Conjunctive. Conjunctive statement. Conjunctive statement. The conjunctive statement, x and y is true, important. This is true if both x and y are true. Is true if both x and y are true, and is false otherwise. If both are true, this is true, otherwise it is false. So as a result you are getting, thus the conjunctive statement x and y is false if at least one of x, y is false. If both are true, x and y is true. Otherwise, it is false. So, very important to understand how, when you are giving something, you have to talk about both sides. When it is true and when it is not true. That's why. Because if you don't say, I have in the conjunctive statement x and y is true if both x, y are true. If I didn't say that n is false, otherwise you don't know. Do you understand what I'm saying? You have to be said. You have to be told that when it is false. If both x and y are true, conjunctive statement x and y is true, otherwise it is false. That means if at least one of x and y is false, then the statement is false. So that means x and y is again, x and y are statements in maths. As a result, x and y, this one, is again a statement in maths. Why? It is either true or false. That is the reason. Notice that x and y can be reworded as, you have, these are not that important, but anyway, he may be using it here and there, x and also y. Sometimes you can write like this, or both x and y are true. Both x and y are true. Or x but y. Because this is, we don't usually write like that. X comma but y. We write that way when there is some contrast between x and y. It's not in the same lines, x but y. And y is different from x, but still true. So they all mean the same thing. X and y, x and also y, both x and y are true. X but y. Then you have to write a comma. So there is the meaning of conjunction. For instance, 2 plus, I have written here in your notes now, you can say, for instance, 2 plus 3 equals 5 and 9 minus 2 equals 7 is true. If this is true, let me write 2 plus 3 equals 5 and 9 minus 2 is equal to 7 is true. Because this is true and this is true, whole statement is true. If I make a proof, 2 plus 4 equals 6 and 2 plus 5 equals 8 is not, make it is not. Why? Even though this is true, this one is false. When one of them is false, the whole statement is false. Now there is a problem, however. Suppose somebody give you a question, statement, conjunctive statement. Say y plus e is rational and y minus e is I have not written in your notes, so can you take it down? Y plus e is rational and y minus e is someday it will come, but not I haven't not done. Conjunctive statement. Y plus e is rational and y minus e is rational. Is this true? Is this true? No. Is this one true? Please look at the board. Is this one true? First part. Is the second one true? Is the conjunctive statement true? How do you know that first one, 5 plus e is rational, is not true? How do you know?
Y is not rational and E is not rational, therefore 5 plus E is not rational.
Kutava? This son said 5 plus e is not rational. No, 5 is not rational and e is not rational. Therefore, the sum is not rational. I don't agree with that much because root 2 is not rational. 3 minus root 2 is not rational. But when you add them, answer is rational. When you add them, answer is rational. You got the no. Anyway, it's good that the answers given by you, I told you, don't have to be correct. Most important thing is, don't just answer without thinking. Think about it and answer, then if it is wrong, it is better than you learn a lesson. If it is correct, you don't learn anything. Then you think, oh, I know it, I am correct. You see what I am saying? It's better.
So, 3 plus root 2 is rational?
Yes. No. I said 5 is irrational, this is irrational, answer is not rational. Because he said by a mistake, phi is irrational and E is irrational, therefore sum is irrational.
It's a broad statement to prove, right? Like, you can't say rational plus rational.
Exactly, that's what my example.
Yeah. But like, rational plus rational should be rational.
Yes.
But you can't say irrational plus irrational is rational or irrational.
Irrational plus irrational can be irrational.
Or rational.
Rational can be both. Now, the whole statement, however, y plus e is rational and y minus e is rational. This conjunctive statement is it true or false? Whole thing. Think about it for 1 or 2 minutes. Your answer does not have to be correct, but answer after thinking. Because you are going to learn.
Is false.
This one is conjunctive statement is false. What about that?
False, right?
False. Do you do that?
False.
Can you prove it is false?
Certainly.
I have a problem.
Yes. This sum has a proof. What is it?
Let's assume 5 plus e is rational
Mm-hmm.
and 5 minus e is also rational.
Mm-hmm.
Okay, so when you add together,
Mm-hmm.
in the right hand side it's rational plus rational, so therefore it should be rational.
Mm-hmm.
Then you'll get 2 5 equals a rational number, then 5 should be a rational number, but 5 is not a rational number, therefore the whole statement is false.
Very good. Everyone follows his answer? If you don't follow, I can repeat what he said. Okay, it's good. But he said no, that 5 plus here, if we have this conjunctive statement says 5 plus e is rational and 5 minus e is also rational. Then we have to know whether the whole statement is true or false. If 5 plus e is rational, then 5 plus e is a rational number. Then 5 minus e is also a rational number. Rational numbers are like m over n and l over a over b, where this sort of numbers, fractions, rational numbers are fractions. So if you add two fractions, you end up with a fraction mb plus na divided by nb. So addition of two rationals is a rational, right? When you add this rational number to this rational number, you will end up with a rational number, right? Do it? If so, this is a fact. Addition of two rationals is a rational. This is the proof, and I have not written like a proof, but this is the proof. Sum of this rational number and this rational number is this rational number. Sum of two rationals is a rational. If this one is rational and this one is rational, then this one plus this one equals 2 5 is rational. If 2 5 is rational, then multiplying 2 5 by 1/2, product of two rational numbers is again rational. Because if you multiply m over n times a over b is ma over nb, product of two rationals is a rational. 2 5 is rational, 1/2 is rational, you multiply, then you get 5 is rational. That is a contradiction. You understand it, Tana? So, the thing is this, sometimes you have conjunctive statements. Now this one, you don't know whether this is true or false. You don't know whether this is true or false. I guess nobody knows. When I say you, I'm wrong. Nobody knows. However, we all know that this whole statement is false. You got what I am saying? In a conjunctive statements, if we know that both are true, we know the conjunctive statement is true. if we know that at least one of them is false, then you know the whole statement is false. So here we have a conjunctive statement which is false. However, we don't know whether any one of them is false. Nobody knows. When I was writing the book, world didn't know. If you cannot check, I will check it next day. Because you see, I am trying to come to this class still. I am a different analysis person. That's why, because the difference of the book. We know this statement is false. But at the time I was writing the book, nobody knew whether this answer is true or false. Nobody knew whether this answer is true or false. I am sure still nobody knows. Though people say I have a PhD in mathematics, I am going to PhD in math, I'm good. Nobody knows whether this one is true or false. Math is such a subject. Nobody knows whether this is true or false. Nobody knows whether this is true or false. But we know the whole statement is false. Do you see? So it is very important for here, when you have a statement like this, you may know the truth or falsity of the whole statement, while if it is true, however, you know both of them must be true. If it is false, all you know is one of them is false.
In this case, so the previous example, 3 plus root 2.
3 minus root 2.
Yeah, you can take like 3 plus root 2 and minus the root 2.
Yes.
For the other way. So
Yeah.
So then in that case only one is false. For this case I don't know, but if you take 3 plus root 2 or 3 minus root 2.
You are saying minus root 2 here,
Yeah.
3 plus root 2 here,
Yeah, and then you add up.
and then what's the difference?
Yeah, no, yeah. When you add it, it's a rational, right?
Yes.
So then I'm saying for the
Up one is also adding rational.
yeah, but I'm saying 2 sides of it, you can prove that only one could be true, but not both.
I'm not getting what you are saying. To me, here this one is irrational, this one is irrational, some is rational.
Yeah.
Your example, following one, this one is irrational, this one is irrational, some is also rational as well.
Yeah.
So no difference among the two examples.
Yeah. No, I was thinking can we do the subtraction thing? Can we get if you subtract 2 irrationals, is there a case where we get an irrational?
By subtracting irrationals, you are asking me whether
Yeah, there is, right?
Of course, no? I bet you get 3 plus root 2 is irrational, root 2 is irrational, you subtract.
That's what I was.
Yeah.
Yeah.
So these rational and irrational, they are very dangerous numbers. Very dangerous numbers. However, a lot of fun. I have tried very. What is Euler's constant? That's right. 1 over 1 plus 1 over 2 plus 1 over 3 plus and so on plus 1 over n minus natural log n. This one has a limit. I don't know whether, don't take it down because we are coming to them in the course, analysis course. So far we are talking about logic. This is called gamma, Euler's constant. Actually this one, I have tried this one, so hard. Because I was good in analysis. I was good in analysis. I tried so hard to prove that I thought this is irrational. I tried for years and years. Oh my gosh, I got grey hair, so I have to try. But I think somebody else proved it, that this is irrational. So these rational irrational problems are so tough. But you guys are very young and bright, no? Take one problem and don't try to write the proof. Think about it. What can go wrong? Think about it. That's very entertaining. This one, oh my gosh, how much I tried. This kind of very famous problems, for some of them, oh, I have given my full effort without any success. So now you got the meaning of conjunctive. It must be clear now. Conjunctive statements are connected to two statements, either true or false, connected by the connective, logical connective and. So the conjunctive statement x and y is true if both x and y are true, otherwise it is false. That means if at least one of x and y is false, then x and y is false. You have to be careful when I say one of x and y is false, then x and y is false. In one hand is English and other one is logic hand. When I say x and y here, this is logic hand. One of x and y, English hand. So don't misunderstand. Anyway, so we understand the meaning of conjunctive statement. So very important, however, from this example, you learn a lesson. There are some conjunctive statements that you know is false. You know are false. Some statements here you know there is one statement which is false, but you know which one out of the two statements, which one is false, you don't know. Actually, the world doesn't know to this day. It is amazing in a way. You can try them. You see like Then America, I told you the other day. One day I was at Ohio State. They have a problem solving class in summer. My professor was a professor. He is also, they are good analysts in the world. Professor Baishansi. So I was the best, or if among the best analysis students there. There is another guy called Rafael from Mexico. Both of us were very good in analysis. Problem solving classes for in summer for all the students in the country. So bright guys like him, and they come. So student asked, Prof asked what are the typical problems. Then the students pointed out this problem, one problem that we could not solve. Then Prof asked me, did you? I said, no, I couldn't. He asked then, it's Raphael, did you? No. Then let me try. Prof went to the board. Prof went to the board, he is writing this and that. He took like 2 minutes. A boy like him. From back, he stood up and ran to the board. Don't waste our time. Give me the piece of chalk. Over there, we should write on the blackboard by chalk. You are wasting our time. You go over there. Let me do it. He wrote the solution within 3 lines. Because young minds, no. Because now I am corrupted, no, because many people have told me this and that. He used mean value theorem. I guess some of you may know already, otherwise you are going to learn in the analysis course. He applied mean value theorem. Then the next thing is, then Prof asked, would you mind coming to Ohio State for the PhD program? Who wants to come to Ohio State? I'm not coming. but in Sri Lanka, if you talk in front of anybody else, that's the end of your career in this country. Anyway, so I guess I am going to assume you learn the meaning of Uta. Now you have an understanding about conjunctive statements. And though you have an understanding, it will take some time to get used to this thing. So now let's go to next one. I guess I have to eat one more egg, scrambled egg at least, to clean the bowl. It is so hard you don't see it. Because this pen is not that type of marker. I guess I am tired by cleaning the book. Okay, conjunctive statements. Then let's go to next one, disjunction. We studied conjunction, now disjunction. Though these they look easy, complicated. Oh. Anyway, so you have the notion. It says a statement of the form X or Y. Where X and Y are statements is called a disjunctive statement. Over there and over here O. Disjunctive, you use O. The disjunctive statement X or Y is true if at least one of X, Y is true. For the conjunctive statement, both must be true. Here, at least one of X, Y is true. One is enough, more than enough. And it's false otherwise. Thus the disjunctive statement X or Y is false if both X, Y are false. If both X, Y are false, disjunctive statement is false. We know if both X, Y are false, X and Y conjunctive statement is also false. Anyway, so this disjunctive statement is of the form X or Y, where X and Y are statements. The disjunctive statement X or Y is false. The disjunctive statement X or Y is true if at least one of X, Y is true, and is false, of course, otherwise. Now, for instance, you take examples 2 plus 3 equals 5, or 4 plus 5 equals 6. This is 5, you cannot see it. This one is true. You get used to this thing by next week right away. Then 2 plus 3 is equal to 4. 4 plus 5 is equal to 7. It's not. Since this one is true, this disjunctive statement is true because this is false and this is false also. Second disjunctive statement is false. Now, however, here there is a thing. you don't have to write because it is in your notes. I say, did you observe that our word O in mathematical logic defaults to inclusive O? As a result, to prove X or Y, it is enough to prove that just one of XY is true. We don't need to prove the other one is false. We don't need to prove. If you want to use exclusive O, because here we spoke because both of them can be true now according to our definition. So it is inclusive. Exclusive means one of them is true, other one is false. One of them is true, the other one is false. I mean, that's not important for us, but some of you are going to do engineering, and this daughter told me, so to them it is important. Exclusive or inclusive. For maths people only, inclusive. You understand how exclusive means? Exclusive O and inclusive O differ. Inclusive means either one can be true or both are true. In exclusive means one of them must be true, the other must be false. Exclusive. You exclude the other one. So that is, it's not important for, I mean, sometimes it may come in maths, but in my life I didn't get it. Maybe that means I didn't do enough maths. If you want to use exclusive O, I say something here, you could use a statement such as either X or Y is true, but not both. That is one way of saying.
It's the negation of if and only if, right?
Eh?
If and only if and exclusive, inclusive and if and only if. So both true, if both true, the statement is true. If both false, true. If one is true and false, then false. The other, exclusive is the other.
We don't use exclusive O in general in our course, unless otherwise you are told. Unless otherwise again you are now. Don't worry about it. Then we are going to learn something very important. By the way, now look at this one. 5 plus E is irrational. Oh, 5 minus E is irrational. I guess, am I going very slow? Maybe I have to explain this thing. Sometimes maybe next day it's not enough because we have to cover quantifiers. Where am I? 5 plus E is irrational or 5 minus E is irrational. This is, I guess, disjunctive statement. What about this statement? Is it true or false? Buddha? True. He says true. Buddha? You are the one who replied to that one. What about this one?
It's the same thing. It's the conjunction of the other sentence. Therefore, since
No, here we have the
negation. Sorry,
we have
negation of
irrational. No, here I put irrational.
yeah.
True. True. Can you prove it if you want? Yeah, though, but in maths, it's good to guess, but there is a limit to guessing.
You can guess the assumptions, right?
Eh?
You can guess the assumptions.
Yes, yes, yes.
We proved like either one of them must be irrational.
Mm-hmm.
So either one of them is irrational or both of them has to be irrational. So that statement is true according to our definition.
You, Puta, you also see that this is true? Huh?
I guess yes.
I guess.
If the addition of the two is irrational, like we got earlier, and then if the addition is irrational, then the both should be irrational, then both are true.
I can do the same.
I bet you better anything. Irrationality.
I can do
Oh.
proof in the same manner. But let's assume like the statement is false. Let's assume.
Assume this is false.
Yeah, statement is false. Then phi minus e is rational, and phi minus e, phi plus e is rational, and phi minus e is rational. If the statement is
That
false.
statement.
Yeah.
Yeah.
But we already proved that that is false.
False.
That is false because we thought the initial statement was false, then the initial statement must be true.
Then this one must be true.
Yeah.
Excuse
Do
me.
it. Yeah.
Can we say the second statement is a negation of the first one?
Yeah.
So
This
if
one is the negation of that one.
first one, so since the first one is false, the second one should be true.
That is more than
Do you know that negation of that one is this one? Do you know? Yes?
it's a demo controller.
So we haven't done negations yet, but you know it, right?
Yeah.
So anyway, now everybody knows now this one is true. The reason I wrote this one is because we don't know whether this is true or false. We don't know whether this is true or false. But we know that the whole conjunctive statement is true. Just because the disjunctive statement is true, you cannot say they are component statements. You cannot say anything about it. But you know, one of them must be true. One of them must be true. That's what we know. So,
If you said like rational there, it's really hard to prove, right?
impossible. I needed a lot. So now we have some idea about conjunctive and disjunctive statements. Disjunctive statements, our O is inclusive O when we say it is true. Both X and Y can be true. In somewhere in engineering, I cannot remember. I knew them when I was doing math special, because I used to give tuition, not to a lot, one or two students. But I went to University of Moratuwa, Kuppidana කියලා. I used to go there, මට ආම්පාරන් දෙනවා. I ate offers and everything there. The important thing is, in a disjunctive statement, when it is true, all you know is at least one of them is true, but you know which one is true. Over here, the same story. When a conjunctive statement is false, you know at least one of them is false, you don't know which one is false. Again, here we used, my daughter told us that we all took it, by the way, not only her. Negation of that is this one, or negation of this one is that one. Next thing we are going to study negation. Though these look easy, I mean, finally this is mathematics. Oh. And when I say mathematics, analysis. Very simple things. The whole mathematics is made of two binary operations and these five connectives. Only 7 things. Some people say it is difficult. And now we ran into so many difficult problems today itself. You are not going to try that. You should try. You are a daughter with a 5 class is rational or irrational, if you can prove it. Oh. No, I am not kidding, because some of you may think of, in a way, completely different from the rest of the world. It is a possibility. What happens is that now we are derailed no, in a way. There are also a way of thinking. Now, when you did A level or went to campus, or we were trained by the others. Now we are not thinking the way we want. We are thinking the way our teachers want, the way they like it. That is the thing. Okay, now let's go to negation. Negation is a very important one. Let capital X be a statement. The statement X is not true, or X is false, or it is not the case that X is called the negation of X. It is very important for you to be able to write the negation. Because, for instance, to say, understand, let's say this daughter, I say she is beautiful. For somebody to understand, now you can see her. To somebody else, I go somewhere else, oh, there was a daughter in my class, he was very beautiful. Then that guy has to know the meaning of not beautiful also to understand that she is beautiful. This is the very important, most important thing in maths. Most important thing. You just cannot say, oh, I understand. If you don't understand the negation, that means you don't understand. Alright, okay. So here what I say is that X is not true, X is false. It is not the case that X is called the negation of X. The negation of X is true if and only if X is false and is false if and only if X is true. Now say X is not true. Or let's take one of them, which has the best English. It is not the case that. So this is the negation of X. This is true if and only if X is false. This is false if and only if X is true. So this is called the negation. We have to be able to write the negation of what we study now. Conjunctive statements, disjunctive statements. We already agreed that we know that this the negation of that one is this one is that one, like that we said. That's very good actually. For instance, the statement, it is not the case that 2 plus 3 equals 4 is a true statement. So you have to can be a little confusing. 2 plus 3 equals 4. It is not the case that 2 plus 3 equals 4 is a true statement. And the statement 5 plus 6 equals 11 is not true is a false statement. So negation is the opposite. So we should be able to write the negations of everything we learn. Doing analysis is actually nothing but writing or proving or disproving. Disproving means proving the negation. And doing analysis is that. Then now well, the kakari bonni mon de la dola. Because terang lain ada patangga penggan tawala ada. You warna late. Bukan. The kapon wala bukan.
All එක පිටචලා දීලා තියෙනවද දන්නේ නැහැ.
ඔව් අපි දන්නේ නැහැ. We are not sure how globally can stay. Will we be able to start on the right time next day?
Yes.
9 o'clock?
Yeah.
Are all of you coming next day? You will, you
I
have
have
lectures. But you have studied these, no?
Yeah, sorry.
So did you get something today from
Yeah, yeah.
when we are doing analysis? You will, again, not much analysis this part.
Yeah, in the book it's not a lot of that.
Mm.
I think in analysis 2 book it starts with the analysis, like in the end there's like continuous functions and
Mm.
first principle and the stuff, and the other book I think
Mm. This is not analysis, this is just
logic.
logic. But these are very important because sometimes, for instance, some Sri Lankan professor was saying that sin delta x, delta x, limit delta x tends to 0 is equal to 1. So I guess you guys know that I am the person who introduced the Maths Olympiad to this country. Do you know it? No? You don't know anything about it. Anyway, I am the father of Maths Olympiad in Sri Lanka. I am the one who introduced. So in one of our Olympiad camps at NIE, National Institute of Education, Maharagama, there was a professor of maths, but he has never studied maths in his life. But somehow his name was Professor of Maths. So he was saying to the, there were like 12 students of it's a residential camp. He was saying in Single, we conducted the camp in Single, English cannot remember, maybe in Single, anyway. So he's saying, ගුරුහරි ඉන්නවනම් මෙතන ඩෙල්ටා x බිඳුව කරා යනවා කියන්නේ ඩෙල්ටා x සමානයි බිඳුවද ඩෙල්ටා x සමානයි බිඳුව දශම 1ද ඩෙල්ටා x සමානයි බිඳුව දශම 0.1ද ඩෙල්ටා x සමානයි බිඳුව දශම 0.5කද කියලා මම ඒක තර්ක කරන්න පුළුවන් කෙනෙක් ඉන්නවා නම් මම ඕන තැනක තර්ක කරන්න සූදානම්. මේ මිනිස්සයා has never studied mathematics. මේකේ එහෙම එකක් ඇත්තෙම නැහැ. Because when he says, in English we say, when delta x tends to 0, no? He thinks that delta x get legs and slowly walks to 0. That's what he wrote. The people have very different opinions. This is absolutely a logical thing. When somebody says, derivative of sin x is cos x, this is not in this world. This is definitely an absolute logical thing. Absolutely a logical thing. It's not the thing in this world. It's 100% logic. When we say this is 100% logic. Somebody who doesn't know this thing, he will limit when delta x tends to 0, and then delta x walks close to 0. Like that. Anyway, since we are not aware of the time, shall we quit here?
Prabhat sir is on.
Huh?
Prabhat sir has come to the meeting, joined the meeting again. He can ask.
Prabhat,
Oh, sir.
now the time is 12:03, 3 minutes past 12. We
Yeah,
agree.
you can stop.
Okay.
Yeah, it's okay. It's okay, sir. You
Huh?
can pick up. Yeah.
Then.
I was waiting if you take a break. Maybe take a break.
Did you listen to what we did? No.
Yeah, I was you do it, yeah.
How was it? How was it?
It's good, but it's, I don't know if it is difficult enough. I mean, I saw that they're engaging towards the end. But I think it's okay as long as you get the traction, then it is okay.
I guess
I
they.
asked them to.
I'm sorry?
I asked them to, but I think it's difficult enough for them, and then they're learning something.
Yeah, so this is the first day, I mean, even in logic there are difficult things. Yeah. Okay, thank you.
I like the lecture too, yeah.
Thank you.
Yeah. I actually never listened to one of your lectures. This is the first time. I never listened to all the stories.
I did not tell them, at the very beginning, of course, I discussed something, but didn't tell them my stories. I don't know whether they will come next day if I had told them my stories. Okay, then let's quit for the day, no?
Okay, yeah.
Yeah. Done. Great.
Okay.
Okay, thank you.